So, good morning. I will talk a little bit about open design and open manufacturing on the ARM ecosystem. So that's my home in Brazil. It's a center. We have there around 60 engineers. The first floor of this building, it's a complete SMT line manufacturing facility. So we do believe that in the current moment, the IoT industry is pushing the limits of our industry. The way how we will design, manufacture, and deploy Internet of Things is completely different from what we did in past. In past, when we had designed computers and smartphones, one solution fits to all. We have this model of one-to-one computing. One human, one computer, one laptop, one desktop, one smartphone. But things are changing radically. We do believe that in a few years, for every human, we'll have hundreds of thousands of computers. So that will radically change the way how we will design these new computers. I belong to the university, so it's not the purpose of a university manufacturing things. We do research and we do education. But also universities everywhere, they are platforms for innovation. I see Chinese colleagues, I see colleagues from Europe. We know that the universities in China are having a very important position helping China to develop itself. That happens everywhere. So in our case, we have the university, we have a design center, LSI Tech is a professional design center. We work with companies like Huawei, Samsung, LG, Boeing, helping these companies with their design things. And then we have a number of agencies that are responsible for the business part of it. We have NGOs. Well, an NGO, yes. For example, at this moment, we're doing the analog switch off. It's a country with 200 million people, 60 million households, and we need to distribute 20 million set-top boxes. The government just created this NGO, gave them $5 billion US, and these guys need to distribute 20 million set-top boxes and digitalize 5,600 cities. So yeah, sometimes you need non-governmental organizations to do some kind of work related to business in society. But also we have startups, we have industry, and we have government. In our vision, usually companies, they see society from the money point of view. They want to collect money from society. But from the university point of view, we want to see the benefit, the progress, the human evolution, no? And in the end of the day, we are all humans, and I truly believe that everyone in this room has the same beliefs. You know. So as I mentioned before, the IoT revolution is pushing the limits of our industry. Just to give an example, the barrier of one-to-one is being broken. We usually imagine one cell phone per human, but take a look in Brazil. 200 million people, 250 million cell phones. Yes, many Brazilians, if you exclude old people, children, you will see that a lot of Brazilians have 2 or 3 cell phones. Who one in this room have more than one cell phone active? It's happening. So what that means, that in near future, maybe we'll have 10 cell phones. One embedded in your car, another embedded in your body, another in your dog. So because that, we need to reinvent the way how we deploy IoTs. But we realize that none of these cell phones are being designed in Brazil. And then when we asked common people, who designed cell phones? Nobody knows. So, that is the IoT revolution in theory, but in practice, we know that will not work. Why? Because the gap. Mind the gap. At the same time that ASIC complexity grew almost 60% per year, we, Linaro people, software designers, we cannot pace the same rate of deploying software, boards. And before, when people talk about the design gap, they thought only about software. And the gap is not about software, it's about everything, the whole ecosystem. Software designing, manufacturing, certification. We need to put all pieces together. When we see the hard time that we have in our companies, is because customers, they don't want a single LG, Samsung, or Huawei cell phone solution. They want diversity. And sometimes we are anxious about this diversity because we know how hard it is to deploy this product diversity. And that's about the gap. The design gap is much bigger than only software. It's about everything, including manufacturing. So, here's our Fab Lab. Yes, it's a factory. It's a state-of-art Panasonic manufacturing line, but also is a lab, because we don't want in this machinery targeting high volumes. That is responsibility of traditional industry. What we're targeting here is innovation. How we can take advantage of this infrastructure to help people that want to do innovation in the field, and sometimes doesn't have the means to work on a small series. So here is our infrastructure. We have everything from layout, schematics, RF simulation, to manufacturing, including screen printing, pick and placement, and the oven. And particularly, we are not interested in things that industry are doing, so we doesn't do PTH, but we do a lot in terms of fine pitch SMT. Just to give an idea, we can inject 60,000 components per minute, because just these machines are fast. Probably have you heard about Industry 4.0? Have you had a chance talking with Panasonic people or Fuji people or Siemens people about the implications of the 4.0 wave in this industry? It's amazing. The production rates will be even more, but there is a big mistake because everyone is looking for low cost, high productivity, high quantities. And the problem from the design point of view is still there. Sometimes we need small quantities in the early stages of the design process. And that's something that big companies doesn't take care. And that hurts us. That hurts the Linaro community, the design community. So, what is cool is because these big machines are also becoming smaller, we have also high precision small machines that can do really small series, let's say 10 boards, 5 boards, 20 boards. So we have this big machine that has 25 meters, almost 100 feet, but also we have these small ones. So that oven is this size, and very precisely, we also have the same resources of the big machine in these small ones. Everything target to quick prototyping, quick deployment, not only for research, but achieving industry standards. Unfortunately, I spend a lot of money keeping all this machinery industry certified. And that is important because the bridge between research and real industry is also narrowing. Also, we have equipment for testing, verification, certification. That's something, usually certification is very expensive, but that's not a problem when you consider high volumes. And what happens when you need to certify for small volumes? The model doesn't fit also. So we come out, since Linaro is about sharing software, why not we start to share certification profiles? If someone in this industry certifies something in China, share with someone in Germany or in Brazil, so we can accelerate the deployment of this industry too. So a lot of equipment for certification, including wedge bonders, microscopy, three-dimensional volume-based analysis, PC routing, OWIN, we have available. And finally, we have equipment to do the signal analysis too. So, many people are asking if we can manufacture the 96 boards. We say yes. At this moment, we are manufacturing some boards from a company named Limaker. Unfortunately, they are not in here today, but we licensed from them the design of the board named Guitar. And in our machine, using only 20% of its capacity, we are being able to manufacture a board in only 75 seconds. So in less than 1 hour, we can manufacture something like 45, 50 boards, you know, and then certify them. I have a video about the manufacturing of this board. It takes 75 seconds, but it's quite boring. I will not show that to you. So that is it. In the design gap, before people was focusing only on software problems, we want to enhance and opening the process of manufacturing, and we want to share that with the community here. So if anyone here has some limitations facing manufacturing, please send a note to me, and eventually we can help you guys on this challenge. Thank you. Any question? Oh, the video. Yeah, I hope that it works. Is he on YouTube? So it's a little bit heavy. Maybe I have here in my desktop. Give me just a second. Sometimes online doesn't work well. WP, JPEG, this one. So we have 6 feeders, and that is just one. Oops, I'm sorry. So what they're doing here is placement positioning to test the quality of the precise positioning, you know? So we have 8 heads per feeder. And here is the manufacturing of 4 Limaker's con boards, you know? And we are using the same component because the idea is do a dummy manufacturing to evaluate the positioning precision, you know? That they did yesterday, and today we start to position the real components, and then later, this afternoon, we'll do the X-ray to evaluate the sound quality. because we are trying to guarantee 100% yield. And also we profile already the oven, and that's something that's really cool. We are profiling. We have a profiler with 16 channels. If you guys have some very special certification needs, we have the precision tools to do that. And again, we doesn't need to compete with high-end, high-volume companies, you know. So the idea is to keep small series just to promote innovation. And then you doesn't need to wait in the queue for that, you know. Yeah, so in here, each lead maker needs something like 150 components. In total, we need something like 300, and we did that in 75 seconds, using just one feeder. In total, we have 6. So if we activate, we have the feeder of this size, we have another head for another side, and we have 3. 2 are for passives, and 1 is for high-precision ASICs, with 2 injectors. And then after that, we have the oven with 20 steps. You know. So for the small series, even if we doesn't need to trade money, if you have any problem, we have the educational part too, you know. When I do this manufacturing, we share that with our students to prepare students or future engineers understanding better the manufacturing process, you know. The guy who is advising me, I'm a professor in electronics, but he came to me and said, well, you are a professor in design, but I will tell you what is the main problem. People usually doesn't choose well the components. Is where 90% of the electronics projects fails. Right, Thomas? Thomas is coaching me about that. So, giving future engineers the correct understanding about manufacturing is key for the success of our industry too. And we need to learn it. And we need to keep it a little bit more open for the success, because as I told you, in the future, we will not have a single S7 Samsung winner product. Society will like diversity. Remember, 1,000 computers per human. If we had a hard time designing 1 computer per human, imagine 10 years from now designing 10 computers per human. That will be a real problem to our community here. It's okay? It's fine?
So I have a question. I'm not sure if I can get the microphone or everybody can hear me. So this is all very exciting. And did you consider maybe taking some share of your production time, run time, and offering maker community a cost-effective service for production of PCB, for example? Couple hours a week, you accept some orders from real people, or, you know, who walk the streets, who want to make some PCB and make it for them.
Yeah. In our model, we are the university, so we have problems making money. That's why we just start up 3 companies. And these companies are responsible for the business. And one of these companies just built a business model where, yes, their costs for small manufacturing is reasonable. And in fact, it's cheap for a small series. So we have this dual mode. We want to support the maker industry. But you know, sometimes makers doesn't have a methodology behind. And in here, we need to keep the methodology. So the university is the guardian of the equipment because we need to have our equipment certified. We need certifications for FCC, CE, Brazil. So because that, the equipment needs to be certified. But we are opening part of the production if the community obey the certifications, because it's reasonable and cheap. In fact, it's not expensive. And we have also this small company that is targeting, from the business point of view, manufacturing small cities for business purposes. When you need, let's say, 50 boards, 60 boards, 100 boards, you know. And during this week, when we start to share this idea, we had heard horrible histories of people that are trying to do a small series, even from big companies like Qualcomm and others, you know. So we structurize ourselves, and I am from the university. I am also the chair of this NGO, but I will be very happy to introduce you to these companies that will take care of the business part, including the business for the makers, because we want to make clear to makers the whole structure that considers also. When we talk about the maker space, doesn't mean that it's free, you know, there is also cost associated. And we need to make clear that to the community, you know. Before, that used to be hidden on Foxconn, these secret companies, though, because all are targeting high volumes. As I'm saying, the IoT revolution is requiring from us mid-sized volumes with a lot of diversity, you know. Some people say that we'll have some fragmentation, but it will be part of the contest. We'll not have 1,000 computers per human in 2030 with the single design, you know. A natural fragmentation will happen.
Along those lines, Marcelo, could you go to these small systems that keep going. Nice job, I think. Yeah, those systems, the total cost of those systems put together would be about $30,000. That's a lot of money for a person to have in their home. But if you had a maker lab or something like that, or a bunch of maker labs put together, they could afford to buy those and then spread the cost of them across everybody who would use them. The issue is trying to get people to create the input to those to be successful in creating their design. And that's one of the things university could help with, is to help them understand how to submit your designs to that style of lab so that you will be successful. And also to help you set up with an agency like Arrow or something like that to be able to purchase the components. So that when you submit your design, you will be able to get components from Arrow to be delivered there, they can be manufactured, you pay them a certain amount of money for manufacturing, and you get 1, 2, 3, or 10 boards out of that. Once you've done that, now you've got something which you can submit to a larger machine. If you wanted to have 100 boards, or 200 boards, or 300 boards. So developing that type of flow is something that would be very good.
I will ask a question to you. Anyone in this room produce beer? You know how hard is producing beer, keeping everything uncontaminated, clean. It's the same thing about this machinery. Despite they are not very expensive, we spend a considerable amount of time to avoid contamination, to care about the electrostatic, to keep the certifications. That is what we need for our industry. So this kind of expertise we want to democratize. So Sir asked about the video. It's just a raw video here, but we hope until Burlingame next semester, having a complete video showing the whole processing step. We want to do that in Portuguese, English, and Spanish, maybe in Chinese, because we believe that that is my university side, we believe that young engineers, for the next IoT revolution, they need to understand these processes, you know. The cares, they learn everything at the university, but they never put that in practice about contamination, about electrostatic procedures, you know. Because eventually, if they wish to have this manufactured at their homes, they need to take care about, it's like making beer, you know, you need to take all care to deliver a good product in the end.
Actually, I should clarify. I do make my own beer, but I only made it at home a couple of times because it was too hard to keep the contamination away.
Yes.
So now I go to a place called BUD17-511,
Yeah.
sewing the recipe to anhydrous and by the rate of color. It's exactly the same fact.
This machine is ultra complex. We need to have a visit of Panasonic every month to check everything. And now we're discussing with Panasonic, since we are targeting this small city thing, we want to put the machine on the cloud. So people will be able to track the process. And also, we have a partnership with this German company named LPKF. These two companies are our partners. They need to visit us every month just to keep the machines perfectly running, you know. Because, you know, doing SMT mounting these days is almost microelectronics. The fine pitch components are almost the size of the hair, you know. So precisely position them and precisely keeping them tied and working correctly takes a lot of costs. So it's not about the cost of ownership, but also the cost of maintenance that is very high in this infrastructure. But again, before, all this key knowledge used to be hidden in some high-volume corporations, and we believe that regarding the design gap, we need to bring this for engineers like us, you know. Okay, thank you.